Archimedes, the Greek mathematician and philosopher, gave us a very important principle some 2200 years back. This principle has got wide number of applications not only in physics and engineering but in large number of everyday life situations. Here we shall try to take a closer look at that principle and try to understand the principle from a simple experiment. This statement says that when a body partially or fully immersed in a fluid at rest, there is an apparent loss of its weight, and this apparent loss of weight is equal to the weight of the fluid displaced by the body. So we shall try to analyze this statement in 2-3 parts and try to understand what it exactly contained. Now we have taken a fluid. Here this fluid is essentially water. We have added some color for its better visibility, and this is our object. This object is being suspended from a spring balance, and you can possibly see its reading. It's 200 grams. This is the weight of the body in air. Now I am really going to put this body first partly, then fully inside water. So it will be partly immersed in water first, and then it will be fully immersed in water. So let us see what happens. We will have to focus our attention towards the readings of the spring balance, and then of course we shall focus our attention towards the markings of this measuring cylinder. First let us put inside water partly and see what happens. This particular body has gone partly inside the fluid. Can you see any change in the weight or in the readings of the spring balance? This change, this reduction in weight indicated by the spring balance essentially is an apparent loss of weight as suggested. Now we will raise a very pertinent question that, well, this is a loss, we understand, but why do we call it apparent? That's what we need to check. I hope once you have appreciated there is a loss, we need to show that this loss is apparent. So what we do, we simply bring it out from inside the liquid and see what happens to its actual weight, what we earlier observed in air. Now let us do that. Take out this whatever water it has, let us take it out, wipe it out, and once again let us try to check the weight in the spring balance, and let us see if we get back the good old reading it was showing earlier before it was immersed in the fluid. So you can see we get back the same good old weight. That essentially indicate that whatever weight it showed when it was partly immersed in water, there was a loss no doubt, but that loss is apparent. Now let us look at the second part of the statement. It has stated that not only partly immersed, but when fully immersed, the same thing will happen. Let us see what happens. Now let us put the entire body inside the water, and let us see what happens. Now you will find that now it has gone fully inside water, as you can see, and you can also see that this loss of weight is different because it is fully immersed. And can you see there is once again loss of weight, and this loss of weight is larger because this time I have put up the entire body inside the fluid, or it has been completely immersed in water. Once again we can check back that if we bring it out of the liquid, we shall find that we are getting back the old weight, and that can be shown in this way. Once again I bring it out, I put off the water from it, any water remaining, and can see that we are getting back the old reading. that 200 gram is once again coming back. Now we shall look at the final part of the Archimedes statement of the Archimedes principle. It says that this loss of weight, this apparent loss of weight, is equal to the weight of the liquid displaced. Now what we can do is that take a closer look at the water level at this point of time before I am immersing it inside this liquid. This stands at 150 ml. Can you see it? Can you see it? Okay. Now you can see what happens if I really completely immerse it inside water. Look at the volume where the water level goes up, because whatever water is being displaced by this body will be shown as the increase in the height in the water level, because this part is now being occupied by the body. Once the body has gone inside the water, you can see that water level has come up. Now what is the present water level? It comes out to be 160, 175. Now what I can really do, I can take it out. So there is, we now know that there is a displaced water of 25 ml. So this body displaced 25 ml of water, and as per Archimedes principle, the reduction in weight or the apparent loss in weight should be equal to the weight of this 25 ml of water. So what we can do in this particular balance, we can take this 25 ml of water. You have seen that the displaced water by this body is 25 ml. So what I am really doing, I am pouring in 25 ml of water inside this beaker, and this empty beaker, you can see the weight of the empty beaker is 147 gram. Now what happens if we put on 25 ml of liquid over here? You can see this comes out, this goes like this. Now you can have a look at it. Look at the change in the reading. This change in the reading is equal to the apparent loss shown over there by the spring balance. So this essentially completes the third or the last part of Archimedes principle, that there is not only the apparent loss of the body, weight of the body when it is partly or fully immersed inside a fluid at rest, but this apparent loss is actually equal to the weight of the liquid it displaced. We actually broke up the Archimedes principle into three parts and showed you how these three parts become valid and they really get linked up in a single statement. You will come to know wide number of applications of Archimedes principle in our everyday life. You will have to start from this point only. So you better have a closer look at Archimedes principle, and possibly you can do this experiment and have a better feeling of the things going on. Thank you.